In Search of Soil.
Let's go back to that mineral nutrition. How does that play into this picture?
It's important. Mineral nutrition, there are materials that are in the soil, iron, phosphorus, that are there, but they're not soluble. The plant can't take them up. And so the ability to take up those nutrients is very important. And trichoderma can help solubilize those insoluble materials. And so it can increase the uptake of phosphorus and potassium. Well, potassium doesn't apply because it's very readily available, but iron. And one of the things that the reason for their existence, in commercial agriculture for mycorrhizae, is that they are able to extend way out into the soil. And they do have a very, very wide network of hyphae, and they can even translocate nutrients from one plant to the next. But one of the things that they do, if they solubilize phosphorus and they package it, and then they go into, there's a lobe arbuscule inside the root, so there's a great deal of surface area with the plant membrane, and it transfers that phosphorus into the plant. And the plant, of course, again, it's a symbiosis. The plant then provides all the nutrition and that the mycorrhizae needs. So this is a very beneficial interaction. But in essence, the carbon is 42% of plants. So it's the largest component of plants. And with increased photosynthesis, which you can consider as a carbon as a nutrient, the increased photosynthesis then really improves plant growth because that's a required resource.
How much of an understanding do you think we have at this point of how that communication between plant and microbe works? Like, do we know what signals are actually being sent?
Yes, we do, and especially with mycorrhizae. I mentioned the common synthetic pathway, the common symbiotic pathway. This one is worked out to a fairly well. It's really very, very well known, and it's really interesting because one of the keys, I think, to all these symbioses, microbial symbioses, was mycorrhizae, that they evolved way before even plants were evolving into monocots and dicots. They were very early. They became partners with plants, very primitive plants, and this has been perpetuated out to now.
Hi, everybody. Thanks for watching. Subscribe here to get the latest from the show. Also, be sure to check out some of the great clips and watch the full interviews right here on In Search of Soil.